Welcome to the On-Premise IT Roundtable podcast, the only show that dares to be both on topic or on premise and on location or on premises. Well, usually when it's not a global pandemic. Each time we meet, we bring together a group of IT luminaries to discuss a single concept. In this sponsored episode by Pure Storage, we're discussing Kubernetes storage, and specifically, we're questioning whether Kubernetes storage even needs storage, or if it's just about the data. Before we begin, let's meet our guests.
Hey, Stephen, good to be here. Thanks for having me. My name is Michael Ferranti. I'm Senior Director of Product Marketing at Portworx by Pure Storage, and really looking forward to the discussion.
I'm Adam Fisher. I'm a cloud and DevOps engineer with Ahead. I'm on Twitter at BonzoVT.
Hey everybody, this is Larry Smith. I'm a kind of jack of all trades, DevOps engineer, automation, whatever, get me into things. You can find me on Twitter at Mr. Ellie Smith Jr.
And I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT, and you can find me on Twitter at sfoskett. So as a storage guy, I've been watching the world of containerization and cloud applications with some level of trepidation, because frankly, it seems to me that applications are moving beyond what I would consider traditional storage. Essentially, it all comes down to state and statefulness. And without state, you can't even have storage. Now, of course, applications need storage, but frankly, cloud applications need something a little bit different. And Michael, you and I were talking about this earlier. I wonder if you can kind of set the stage by just explaining, how do Kubernetes applications use storage, or how do they store their data, which may be the better question.
Yeah, it's a good question. I think, let's start there definitionally, because I think this conversation can go a lot of different directions. Because ultimately what we're saying is, yes, data services on Kubernetes, your databases, your streaming services, your big data, AI, ML, they all need storage, but you can't stop at storage. You really have to think about a data management strategy and what that means. And we'll get into that. But when we talk about stateful applications on Kubernetes, what we mean is a container. And the container itself is always stateless. It's a process. Even if it's a MongoDB container or a Postgres container, that container itself is immutable and it's stateless. But a database, for instance, MongoDB, wants to write data, and it wants that data to be available even after the pod or the container fails, or the host that's running that container fails. It wants to have that data available. And so that data is stored in a volume. Usually a block volume, but in some cases it could be, a file volume. And that's what we mean by a stateful container. It's not the container itself that's stateful. It really is the volume and the ability to manage that container in an automated way via Kubernetes, but in a way that allows that data to be accessed, moved, preserved, encrypted, all of the operational verbs that we're used to. That's what we mean by Kubernetes storage or Kubernetes volume.
So Michael, when you talk about statefulness and things like that, when do you typically see when people are generally ready to dive in and say, I'm going to deploy these Cassandra? I mean, we don't have to go, let's just use that as an example, from an HA or clustering perspective, and say, this is a good candidate for Kubernetes. This is a microservice that we can break down. When you start talking about the data or the storage, like we're talking about, how do you get things like that replicated, or basically between data centers? If I have failover, DR, things like that, or do we really not care? Do we think of things like, when we think DR back in the days when we have, active standby sites, things like that. But what about just the YAML file? What about how we defined our applications as that YAML file that we deploy as a manifest, and just kind of go with, hey, it's here, maybe I can go over here. How do we get that data, across different locations, data centers, cloud providers, whatever?
Yeah, a lot of good questions there. So I'll take them a little bit in order. So the first is, when are people ready? In my experience, people are ready to run their databases on Kubernetes when they experience the pain of not running their data services on Kubernetes, right? So Larry, you're a DevOps engineer. You've been on PagerDuty, right? And when a microservice that you're responsible for running, like, goes haywire in the middle of the night and you have to fix it, like, that's a really good time to think about how automation could actually make my life easier if I didn't have to wake up in order to fix that service. So when Docker really became popularized and developers started to use it en masse, and they realized that this is actually a great way to encapsulate and deploy my applications into my production environment, but now I need to manage all those containers, hence Kubernetes comes along. These were people that were operating applications, right? These were not the IT people that were just responsible for ops. They were DevOps engineers who were building, running, and then managing that application themselves. They were the ones who felt the pain, and they were the ones who first started to say, you know what? If I'm going to be responsible for running an application in production, then I'm going to use automation to make sure that I can ease the application, the management burden on myself. And Kubernetes is a great way to do that. Your second point is, well, if I've got a YAML file, right? If I'm using best practices around infrastructure as code and declarative deployments, then I've got a YAML file. Do I still have to think about, like, data protection and replicas and all of these things? Fortunately or unfortunately, the answer is yes, absolutely you do. Because a YAML file is just a text file. Are you going to tell me that because I have a text file that I can put that on some server somewhere and now, like, my users can, access their shopping carts on my e-commerce site? No, it's a laughable premise that just because I have a YAML file, my infrastructure behaves in any particular way. Now, the distinction that we started the show with that I think is important is that, likewise, just because you have storage doesn't mean that your users can continue to access their shopping cart online, because storage isn't magical either. It's a combination of the declarative and automation framework that Kubernetes provides with storage systems that understand those primitives, understand those APIs, and together in the back end, transparent to the user, we can actually have a system that, while not magical, seems magical to operators, because when there is a failure, that application can be brought online seamlessly and transparently.
So that's a great comment about the operators, because, yeah, I mean, I can think of traditional applications and traditional IT admins who, typically your storage admins, your virtualization admins are the ones who are responsible for keeping an application up and running. But now you have this newer modern architecture with different types of operators who are deploying applications, who are dealing with containers and clusters in a way maybe that developers didn't necessarily do in the past. So these applications still do require, on some level, some type of disk or data to write to. So what do you see that operational standpoint in these modern architectures? Who's going to be concerned about the storage? Because it has to be there on some level.
Yeah, it's a great question. I mean, the whole transition to DevOps is changing roles. Who's responsible for infrastructure in a DevOps world? That's a great question. Is it IT ops? Is it DevOps? Is it developers? Everything in life is a spectrum, right? There are shades of gray in everything. I think the big change with a move towards DevOps is that infrastructure serves a purpose, and the purpose of infrastructure is to allow us to run the applications that the business requires. And so a DevOps team who's responsible for a microservice, right? Whatever, the shopping cart in my earlier example. It's not like that team also needs to be the procurement team for the on-prem data center or to manage all of the AWS instances. but they're kind of the business owner, if you will, of that microservice. And so they're really responsible for advocating that the infrastructure is able to support the application requirements. And what we're seeing is that that is increasingly, it's kind of a partnership between traditional IT ops and DevOps engineers. It's kind of no longer that IT ops has a menu of infrastructure and you pick from that menu and then you're just happy to have it. It's more, okay, let us understand what is it that you're trying to run. Okay, Kubernetes needs to work in this way. So you need, VMs or storage of these attributes so your automation can work. We're starting to see that more and more, where DevOps is not just a receiver of infrastructure, but an influencer on even infrastructure purchasing decisions. That's certainly what we're seeing at Pure Storage and Portworx. When we go into a customer and we sell them Portworx, sometimes there's infrastructure components that get brought along with that, because ultimately infrastructure team, they're not as close to the business requirements and to the business units. The DevOps team is often closer there and can do a better job of describing the actual business needs than IT can necessarily.
So Michael, I'm hearing a lot of good stuff. I mean, this all resonates pretty well. Adam, you probably see it day in and day out. I see these things, and one of the things that I think a lot of people, or at least maybe struggle with from a, let's go back to the DR or the backup. Okay, we've got data, traditional IT, VMs, things like that. We had data from a database perspective. Maybe we use some product to do data backup, retention, whatever, have it shipped off site, whatever, and be able to restore. Now, obviously, we know how many companies really were successful at DR, but the reality is that it was there as long as you architected it. When we're talking about containers and we're talking about Kubernetes and we're talking about these different elements, how can I ensure, it's like Kubernetes, some people, it's like a big black box, right? It's a thing, but what does it do? It's this, that, or the other. But from a data retention perspective, is there, or how can you describe what it looks like from a container application from, again, using the Cassandra as an example? If I have the data, I have the bits, when I have a scenario where I need to go to another site, I'm going back to the same thing before. How do I make sure that those containers, when I spin them up and their storage definitions and all that they're truly mapped correctly to what data needs to be present from a volume perspective?
Yeah, great question. And your initial question around kind of everything's a YAML file gives us the answer to this question. And that's one of the beauties of Kubernetes. I was having a conversation a couple of days ago where someone was talking about, like, when are customers ready to, deploy stateful applications? And what I said is, once they're comfortable with Kubernetes, the shift to running stateful applications is actually very minor from a technology perspective. It's a very small jump. It's a bigger jump from a psychological perspective. Because once you're used to running stateless applications, you're used to defining your application requirements in YAML. You have, you're used to using various Kubernetes objects like operators and service accounts. You're used to configuration. You have your deployments. You have your services. You have all of these, all of this configuration. That's what defines how your app, what container image needs to run, what other services need to be available in that requirement, what secrets files you might need to access this or that other service. Everything can communicate together. That's a big part of your application. When we talk about Cassandra, you need a couple of other things. You need the ability, when you take a backup of Cassandra, to make sure that it's application consistent. So if I've got a 10 node Cassandra ring, I can't just like snap, and then be able to recover that application effectively. I actually need to kind of quiesce everything. I need to take my snapshot. I need to quiesce everything, flush any kind of pending writes to disk, take my snapshot, unlock everything, and run node tool repair. That's how you take an application consistent snapshot on Cassandra. So, using something like Portworx, we do that for you. We understand the difference between Cassandra and Kafka. And so now I have an application consistent snapshot composed of multiple volumes. And my YAML files that that describe my Cassandra application also describe those volumes. So when I put all of that as a single object into, say, S3 or a FlashBlade running on-prem, and then I recover from it, I'm recovering the data, but I'm also recovering a self-describing application so that I know the container images, I know the configuration, I know the secrets files to make this application run. And as you pointed out, Larry, it's like how many multi-million-dollar DR projects, like just absolutely, like they were the best thing in the world until we actually needed it and it just didn't work. With Kubernetes, it's super easy to test because, well, it's like I just put my backups on an object store somewhere. All I need to do is spin up a Kubernetes cluster, pull down that backup and start it up. Does it work? It's very, very easy to test. In fact, I would say, one of the big drivers for Portworx business is actually this data protection use case. People saying, I really can't run an app in production unless I've got, DR. So they'll bring us in, they'll test it, and it turns out to be really a big driver for our storage business because we're handling the data management aspects for customers. Hopefully that answers your question.
No, it did, and that's great, because I heard another thing as you were talking is, it sounds like, let's say I'm the lazy developer and I've deployed an application in my production Kubernetes cluster and then put in version control. I said, hey, my laptop, it's got the YAML files I described, my whole deployment, all my applications deployed. I needed stateful data sets, things like that. I've deployed it, and guess what? My laptop just blew up. I didn't have a backup. What I think I heard is that something like Portworx could take basically from a backup scenario, if you will, to being able to recover in the off chance, or possibly even re-describe what that deployment looks like, that something like Portworx could actually get the definitions from within Kubernetes itself, all of the constructs that were there, and be able to recover that.
Yeah, exactly. When we take what we call an application backup within Kubernetes, it's the data, of course, if it's a database or queue, key value store, et cetera. But it's also all of the configuration that describes the application. And we're a big believer in GitOps. Like we don't believe that you should have anything that is like configuration that's not stored in Git. But right, the world's not a perfect place, right? Not everybody is religious about every time, I'm debugging something in production because, hey, we're taking downtime. I fix it and I forget to check it back into my Git. And so now my production has diverged from my my version control. And if I restore my application from version control, it may just bring me back to a state before I went through that debugging exercise. So we don't advocate not using version control. We advocate being realistic about, if you've got a large development team, you're going to have drift from your production to your version control, and being able to take a backup of what's actually running in production is really, really useful, not just from a data protection perspective, but also from like a cloning perspective, if I want to stand up a new version of the application for testing or something like that.
Yeah, so all this sounds really great, and certainly, I mean, with modern applications and containers and everything, we know that the desired state is to get as close to stateless as possible. But there's a lot of organizations out there that are still running legacy applications that are talking about how do we move to this kind of architecture. And there's a lot of considerations, especially when it comes to cloud and multi-cloud and different services that offer storage and the ability to run containers, and where you have to think about things like latency and even storage performance for certain applications. So at what point do you take these type of infrastructures and still consider, okay, well, where am I running this application? How close does it have to be to where my data is? And do I need to even be concerned about storage policies underneath if there might be performance issues with my application?
Yeah, so I would maybe just because, and keep things lively, I would maybe say one thing that you said early a little bit differently, that the desired outcome is to keep things as close to stateless as possible. The way I would say that is we want to keep things as well defined as possible, so that we can manage our applications. The enterprises that we speak to don't have a goal to have things be stateless, because if that were the case, then most of their applications couldn't run on Kubernetes. And they're looking at Kubernetes as kind of a enterprise-wide platform to kind of actually implement digital transformation. And that means, they have database and they have to figure out how to run them on Kubernetes. The second part of your question is kind of, well, how does network topologies and infrastructure topologies impact which applications I run and where? I think it's a really important consideration. We see customers really for the first time being able to make pretty sophisticated placement decisions between on-prem and cloud in order to manage those requirements. And sometimes it's about, I'm thinking about, one customer that pops to mind would be Roblox. So they are large scale online gaming community, mainly for kind of tweens. It teaches coding, they play games. So they have over 150 million users. And what's really important for them is the gaming experience. And so they've created a kind of a POP distribution scenario, point of presence, basically their own kind of gaming CDN, if you will. And all of that's running in containers. And Portworx is backing it in there. It's kind of, we're providing storage in those, their colo facilities that are really, really close to their end users. Other customers are making decisions about, I'm going to run on-prem and I'm going to do it on top of, say, a flash array, because I need like really, really low latency access to storage. Whereas that's not Roblox's use case, because, the gaming experience, it's not IO bound. It's just how close can I get to the customer so that, the back and forth of the gaming experience, it's not right. You're not writing data. So I guess I would say customers are looking at the actual application requirements and they're balancing, where does that app need to run in my own infrastructure? If so, on what type of infrastructure in the cloud? If the cloud, which cloud? So, Google has great DNS service. Amazon has great, natural language processing. And so sometimes those decisions are based not on performance per se, but ancillary services that are available in the different cloud providers. And so, I think ultimately that's a question that, the customer works out with us as we figure out the architecture. But the good news is that there are lots of different choices.
Hey, Michael, real quick, do you guys see a lot, and I feel like maybe this is going away from the is data the same as storage, but, I'm thinking about this from the perspective of, I hear what you're saying, right? Maybe I'm a self-sufficient organization and I manage my own Kubernetes deployments on-prem, and maybe I have Pure Storage and things like that. Not to bring, but let's talk for what it is from a Portworx perspective with Pure Storage. And I've got a really good concept and grasp on how we manage that thing because it feels kind of natural, right? When you start talking to customers and they start talking about cloud, we're using Kubernetes, they were using AKS or EKS or whatever. And you don't really think about these things, right? You don't really think about, hey, what does my storage look like underneath because I'm using a managed Kubernetes deployment? Is there a challenge there from a customer perspective to get that understanding of there's some value here that's overlooked from a Portworx perspective that I can put into a managed Kubernetes deployment? Or is there no value in that conversation at all?
I think I hear what you're saying, and let me play it back to you or give you an answer. If I miss the mark, let me know.
That was a terrible question, right?
30 to 40% of our customers are running in the public cloud, and there's just as much value with Portworx in the public cloud as there is on-prem, and it all comes back to the premise or the premises of this podcast, which is like it's not about storage. It's about data management. And so, if I'm running in the cloud, I have storage available to my Kubernetes cluster. It's EBS or it's Google Persistent Disk or what have you. If I'm running on-prem, I might have a flash array. I might have, just some bare metal servers and just some, SSDs in those. Storage is available everywhere. Just like if I have Kubernetes, then I have compute. It may be an EC2 instance or maybe as a VMware VM. It's like compute is everywhere. But what problems does that solve, right? Compute itself solves very few problems for a Kubernetes deployment. Storage itself solves very few problems for a Kubernetes deployment. It's not the ability to persist data that is important. It's the ability to kind of manage that storage infrastructure in a declarative way using YAML files, for instance, or the ability to recover an entire application, even though it's a distributed system composed of dozens of containers, hundreds of pieces of configuration. That's really the value that Portworx provides, and we provide that in a cloud environment just as easily as we provide it on-prem. I think there is, to your question, Larry, a perception that, well, if I'm in the cloud, then it's always struck me as a little bit odd because, people, if I'm in the cloud, then I don't need compute. No, it's like that. In the cloud, you still need something to manage the compute. And that's what Kubernetes does essentially. In the cloud, you still need something to manage the storage, and that's what Portworx does. So we see ourselves as kind of a layer that if you've got, if you're investing in compute automation or application automation, then you need something that does the equivalent for your storage. And since Kubernetes itself doesn't provide that, it does it via mechanisms that it exposes for this purpose, like CSI, then you need something that fits in that layer. I think the confusion might come from, Amazon EBS, as an example, has a native CSI driver. But like anything in life, there's always multiple options, but not every option is equally reliable or valid for a particular use case. So I think that may be where some of the confusion comes in.
I think this gets back to one of the classic discussions in enterprise storage and which is basically how do you draw the line between storage and data? How do you draw the line? What is data? What is metadata? I mean, I could make a good argument that YAML file in a Kubernetes environment is metadata, and that what it's pointing to is data. But frankly, I could also make a good argument that it really is storage, that it really isn't data, because in many cases, what the YAML file is talking about is not elements of information, but in fact, collections of, frankly, storage. So, back to the point here, is this truly, I don't know if it matters or not, is this truly data, or is this just storage in a different shirt?
Yeah, I mean, I think ultimately, words matter. And because enterprise storage, and I don't know if my, bosses are listening to this at Pure Storage, but, because storage, there's a connotation. And, it's not always a good connotation, right? Of like your storage company. That's not the company that you expect to fuel your business transformation. That's not fair. It's not fair that we have that perception of storage. Whereas data, it's very new, it's very modern. It's what drives my AI and my ML. And to the extent that we can pick a word like, have a Kubernetes data strategy versus a Kubernetes storage strategy. At the end of the day, Stephen, I think you're right. It's like we still need to think about the same things, but one puts us on a path to really driving business transformation and meeting the needs of the business, right? Data is what's gonna make us competitive. Storage isn't what's gonna make us competitive. We need to offer services to our customers. We don't need to offer infrastructure to our customers. And I think data puts us more in that path. Again, sometimes life's not fair. There's a perception of the industry being a certain way, right? Rather than try to change that, let's talk about it in a different way and really talk to people about how they can enable the change that they're trying to drive. And I think talking in terms of data gets us there more than talking about storage, even though, at the fundamental level, there's some data that's been written to a disk somewhere.
Yeah, and it's like the old wag's tale. The cloud is just someone else's computer, and serverless doesn't mean there's no servers involved. It just means that the servers are not a consequential element in and of themselves. So I think we need to wrap this discussion up, but I'm wondering if maybe I can get a reaction. Let's get back to it. Does Kubernetes really just need data and not storage? Larry, why don't you go first?
Well, I think, we kind of went around a different angle a couple times, and coming at it from the storage perspective, taking that traditional mindset. And I'm glad we kind of did bridge that gap, I think, towards the end back into the data conversation. And what I'm hearing, and I think Michael just summed it up as well, is that, it is about the data. And I do think that going forward, the conversation should be around data versus storage. Because, let's be real, Steven's a storage guy. He's been doing it a long time. A lot of older mindsets or, kind of down in the weeds, think about storage from that perspective. They don't think about it in the way that we're talking about from a data perspective, I think. No offense, Steven.
None taken, maybe, Larry.
Yeah, I mean, I think that Kubernetes needs data and not storage is a fair premise. But I don't think that means storage is going to go away. I just think that Kubernetes is really shifting who cares about storage and operationally what we're going to do with it and how we do that. So, I mean, I think certainly serving data to customers is the most important business value, but that data has to reside somewhere.
Yeah, and what I would say is, storage is becoming more important as we have more data because it needs to be stored somewhere. But that doesn't, just because we have storage doesn't mean we're solving the business problem that Kubernetes allows us to tackle. So if we stop at storage, if all we do is create a way to provision a volume via Kubernetes the way that we were able to provision a volume from OpenStack, right? If that's all we do to enable new types of applications to run on Kubernetes, then as an industry, we've failed, because that's not going to enable us to, implement, 5G technologies, to implement, AI and ML. All of that is really about your data strategy, and the infrastructure is just a means to an end. So at Portworx, that's really what we're driving with our customers is, what are you trying to achieve with 5G? What are you trying to achieve with machine learning? And let us work with you to just enable that, not just give you a box and then say, have at it. Like that only gets you part of the way. We want to bring our customer all the way to the outcome that they're trying to drive. And that's really about data, not storage.
Well, I think that's, this is one of the key questions these days, especially in this sort of data-driven world that we live in now. I mean, frankly, you could be forgiven for saying that applications today really are only about data and manipulating data and processing data. And that is really what we're doing now in the cloud. So it's not really cloud computing, it's actually cloud data. And that anything that makes that work is basically the key to the future of applications. So I really appreciate this conversation. We do have to wrap up now. Thank you so much for listening. Thank you for joining us, Michael, from Pure Storage and Portworx on this edition of the On-Premise IT Roundtable podcast. Those of you listening, if you enjoyed this discussion, remember to subscribe, rate, and review the show in iTunes. That really does help every podcast's visibility and success. And please do share this show with your friends. This podcast is brought to you by GestaltIT.com, your home for IT coverage from across the enterprise. For show notes and more episodes, go to GestaltIT.com/podcast. Thanks, and we'll see you next time.